right, so on to the second half of this problem, where it asks if g is continuous at x equals -3. So for a function to be continuous, it needs to have three things. The first thing is the limit as x approaches that number has to exist. Okay, the second thing is that f of that number, or in this case it's g of that number, has to exist. And then the third thing is that those two things, the limit as x approaches -3 of g of x, has to equal g of -3. Okay, so they need to be equal for it to be continuous. So the first thing, it splits, the function splits at x equals -3. So we're going to have to first check the limit as x approaches -3 from the left and the limit as x approaches -3 from the right. So first thing is we need to check those, because if those are not equal, then the limit doesn't exist, so then it's definitely not continuous, so it would fail item number 1. All right, so as it approaches from the left, that's this top one, so it's f of x, so we plug -3 in here, so 25 minus -3 squared is 9, so that's 16, square root of 16 is 4. The limit as x approaches -3 from the right, we plug -3 into the one that's approaching from the right, and we get 4. So item number 1, it exists. The limit as x approaches -3 of g of x is going to equal 4. Item number 2, does g of -3 exist? So there's that equal to, so I would plug -3 into this one, so f of -3. So item number 2, g of -3 is equal to 4. And therefore, because those two things are equal, yes, g is continuous at x equals -3, because the limit as x approaches -3 is equal to g of -3. Okay, so that's what we prove whenever it asks for it to be continuous. It needs to check off those three items: that the limit exists, that the value of the function at that point exists, and that those two things are equal to one another. All right, so on to the last one. We've got the integral of x square root of 25 minus x squared dx. So this is actually a u substitution one, so I'm going to just do this so I don't get those mixed up. So this, I'm going to rewrite it from 0 to 5, x parentheses 25 minus x squared to the 1/2 dx. So I'm going to let u equal 25 minus x squared, because we've got a function inside of a function. This would require chain rule if we were doing the derivative, so therefore we need u substitution. So that's going to be u to the 1/2, but then we still have that x in the dx left over, so du dx equals -2x multiplied by dx. Du equals -2x dx, divide by -2, so -1/2 du equals x dx. So we're going to substitute x dx with -1/2 du. And now we do our bounds. So we're not going to use those same bounds because these are u's. So I'm going to plug 0 in. These are x values. So we need the u values. So 25 minus 0 squared is 25. That's my lower bound. My upper bound is going to be 25 minus 5 squared. So that's 25 minus 25 is 0. So now I do the antideriv. I add 1 to the exponent. Divide by the new exponent. That's like multiplying by 2/3. But there was already a -1/2 out in front. So that means it's going to be a -1/3 out in front. And we evaluate that from 25 to 0. So we can use all these in terms of u. So we plug in negative 1/3, top bound is 0 to the 3/2, minus negative 1/3 times 25 to the 3/2. So we've got 0 minus negative 1/3 times, now we do the exponent, power over root. So the square root of 25 is 5, raised to the third, 125. So minus a negative becomes positive, so it's going to be 125 over 3. Final answer. All right.